Welcome to our deep dive into multimodal generative AI.
It's AI that goes way beyond just text.
Yeah, it works with images and videos too, and
And you're especially interested in how this AI can understand what's in a picture.
yeah, or a video.
And also how it can create visuals.
Yeah, from just text descriptions.
We're going to be exploring how this AI can answer questions about images,
Right.
but also how it can generate images and videos from scratch.
So like an AI artist and an AI detective all in one.
That's a good way to put it.
Okay, I'm intrigued. Where do we even begin with something this complex?
Well, we've got two major players in this field.
Okay.
Multimodal large language models, or MLLMs for short.
MLMs, got it.
And diffusion models, think GPT-4V for the MLLM side.
Okay,
And OpenAI Sora as a prime example of diffusion models.
got it.
Each has its strengths, but the big question is, can we combine them
Ooh.
into one AI model that does it all?
Okay, that's a big question.
Which is?
But let's break it down. First up, MLLMs.
Okay.
Now, I know LLMs are the brains behind chatbots, but how do they make the leap to understand images?
Well, imagine you're teaching an AI to read.
Go.
At first, it only understands letters and words.
Right.
But to truly grasp the meaning of a story, it needs to see the pictures, too.
That makes sense. But a chatbot only deals with words. How do we give it eyesight?
That's where visual tokenizers come in.
Okay.
Think of it like translating a picture into a secret code that the AI can understand.
Okay.
These tokenizers break the image down into small chunks and assign each chunk a unique code like a visual alphabet.
So it's like turning a picture into a language the AI can read.
Exactly.
I'm picturing like a giant dictionary, but instead of words, it's full of visual concepts.
That's a great analogy. And two popular techniques for creating these visual dictionaries are VQVAEs and VQGNs.
Okay, so we've got our image translated into AI language.
Yeah.
What happens next?
Now we need to decide how our MLLM is going to use this information.
Okay.
There are two main architectures we can choose from: alignment and early fusion.
Alignment sounds like it's building on what we already have to maybe save time and effort.
Exactly. With alignment, we take an existing pre-trained vision model, something that already knows how to see,
Right.
and build a bridge to connect it to our LLM. It's efficient,
Okay.
but we're somewhat limited by the strengths and weaknesses of that initial vision model.
So it's like building a house on an existing foundation.
Yeah,
You save time, but you're limited by the shape and size of that foundation.
a perfect analogy. And a good example of this limitation is CLIP's vision encoder.
Okay.
It's a powerful model, but it can struggle when there are multiple objects in a scene.
Oh, I see.
Researchers are working on improving these alignment modules with things like Q-formers, locality-enhanced projectors, and token packers
Wow.
to make that image-to-text connection more sophisticated.
Makes sense. But if alignment is like building on an existing foundation, what's early fusion like?
Early fusion is more like raising an AI child from birth, teaching it to see and understand language all at the same time. We're training a multimodal LLM from scratch.
Wow, that sounds ambitious. But I bet it comes with some serious challenges.
It does. Creating that initial visual tokenizer is a huge task.
Right.
And we need mountains of data to train these models effectively. It's a computationally expensive process.
So alignment is the efficient but potentially limited option, while early fusion has a higher ceiling but requires more resources.
Exactly. But the potential of early fusion is attracting some serious players. Google's Gemini and Adept AI's Fuyu are both pushing the boundaries of what's possible.
I'm definitely sensing a theme here: efficiency versus raw power.
Yeah.
It's fascinating to see how researchers are tackling this trade-off.
Yeah.
So we've gone from LLMs that just chat to LLMs that can actually see images.
Right.
But I'm really curious about video.
Yeah.
Adding that time dimension seems like a whole other level of complexity.
It is. Video understanding is a frontier in this field.
Yeah.
Most current video LLMs still rely on analyzing individual frames from a video using techniques similar to those we've discussed for images.
So they're treating a video like a flipbook, basically, analyzing each picture separately.
Essentially, yes. And models like Video Llama and Video Chat even incorporate audio into the mix, adding another layer of information.
Okay.
But by just looking at frames, we're missing something crucial: the movement and transitions between those frames.
Right. A horse in one frame and then a horse in the next frame doesn't tell us if it was galloping, trotting, or just standing there looking majestic. We need that context.
Exactly. And that's why researchers are exploring ways to analyze video segments rather than just individual frames.
Hold on. How do we even get AI to understand a whole story in a video? If it's just analyzing frames, isn't it missing the narrative thread?
That's a key challenge. One approach is to focus on segments like in VTime LM, which uses boundary perception training.
Okay.
This helps the AI identify when events change in a video, creating meaningful chunks rather than just a series of disconnected images.
So the AI is starting to grasp the flow of events, not just isolated moments. That's a big step. But what about really long videos? Don't those exceed the limits of what an LLM can handle?
That's another hurdle. Long videos can overload the AI's memory like trying to cram a whole movie into a short tweet.
So what's the solution? Do we need to build LLMs with even bigger brains?
There are some clever workarounds. Movie Chat, for example, uses a memory consolidation mechanism.
Okay.
As it reaches its limit, it merges similar image tokens together, kind of like summarizing the key points. Other approaches involve turning those long videos into text summaries that the LLM can search through.
Wow, that's impressive. It's like giving the AI speed reading superpower.
Hmm.
Okay, so we've covered how these AI systems are getting better at understanding visual content. But what about the creation side? I'm ready to dive into the world of AI-generated images and videos.
Let's shift gears then and explore the magic of diffusion models.
Okay.
These models take a completely different approach to generation. Instead of building an image piece by piece, imagine starting with pure noise static on a TV screen and gradually refining it until a clear picture emerges.
It's like that reverse time-lapse of a fading photo you mentioned earlier, right? But instead of fading away, the picture is slowly coming into focus.
Exactly. And this gradual denoising process is guided by the input text or other conditions we give the AI. It's like having the AI paint a picture stroke by stroke based on our instructions.
That's so cool.
Yeah.
And because it's this step-by-step process, we have more control over how the final image looks, right?
Precisely. It allows for fine-grained control and often leads to higher quality images compared to other methods.
Okay, that makes sense. But I've heard of something called latent diffusion models, or LDMs. How do those fit into the picture?
LDMs are the real workhorses of diffusion models, especially when we're dealing with high-resolution images and videos.
Yeah, I can imagine that working with those detailed visuals must require a ton of computing power.
You're absolutely right. Imagine trying to denoise every single pixel of a 4K image. It would take forever. That's where LDMs come in. They do all that denoising magic in a compressed space, a smaller representation of the image.
So it's like denoising a thumbnail sketch before creating the full-blown masterpiece. Smart.
Exactly. This makes them much more efficient and has really opened up the possibilities for generating high-quality images and videos.
This is already blowing my mind. So we've got these amazing models for understanding and creating visuals, but can we bring them together? That idea of a unified model, one that can both comprehend and create, is still incredibly intriguing.
It is, and researchers are exploring a few different approaches to combine these powerful techniques. One way is to connect pre-trained models, kind of like assembling an AI dream team.
So we've got our multimodal LLM, the master of understanding, and our diffusion model, the creative genius. How do we get them to work together?
It's all about communication and collaboration. Some methods use tool learning, where the LLM acts as the manager, calling upon the diffusion model as a tool when needed.
So the LLM is the director shouting, lights, camera, action, and the diffusion model gets to work creating the scene.
A very cinematic analogy. But remember, just like in filmmaking, we need more than just separate departments working independently. We need those departments to communicate and coordinate effectively.
So how do we get these AI models to truly speak the same language?
That's where connectors come in. Remember those alignment modules we talked about for MLLMs? Similar ideas are being used to bridge the gap between LMs and diffusion models.
So instead of the LLM just giving the diffusion model basic text prompts, it's giving it richer information, a combination of words and visual concepts.
Exactly. It allows for more nuanced control over the generation process. However, connecting pre-trained models, while efficient, might limit the overall capabilities of the unified system.
Right. It's like trying to build a supercar by bolting together parts from existing cars. It might work, but it's not going to be as elegant and integrated as a truly unified design.
That's a great point. And that's why some researchers are aiming for a more ambitious approach. Training a single unified model from scratch. This model would learn both understanding and generation simultaneously.
Whoa, that's a moonshot. How do you even begin to train a model that can do so much?
It's a massive undertaking. We need massive data sets covering both comprehension and generation tasks. And the model itself needs to be incredibly powerful, capable of handling both semantic reasoning, understanding the meaning of things, and pixel-level manipulation, the nitty-gritty of image creation.
It's like building a brain that can write poetry and paint photorealistic portraits all at the same time.
Exactly. And this is where multimodal transformers come into play. They're being adapted to handle both diffusion and autoregressive objectives.
Okay, back up for a second. What are those objectives again?
Good catch. The diffusion objective focuses on that denoising process, guiding the model to create high-quality visuals. The autoregressive objective is all about understanding and generating text reasoning about relationships between different concepts.
So we're training the model to be both an artist and a storyteller, all in one.
Yeah.
This is getting really deep and I love it. But I'm curious, where does all the data come from to train these massive models?
That's a great question and one we should definitely explore further. These models are data hungry, and they need a varied and balanced diet of information to truly thrive.
So it's not just about feeding them random images and text snippets. There's an art to creating these data sets.
Absolutely. The quality and diversity of the data are crucial for the model's performance. In our next session, let's unpack the different types of data that go into making these multimodal marvels.
I can't wait. This deep dive is already exceeding my expectations.
Welcome back to our exploration of multimodal generative AI.
We've covered so much ground already, from LLMs to diffusion models. It feels like we're on a rocket ship through the world of AI.
We are indeed moving quickly. Last time we were talking about the data that fuels these models, the different types of information they need to understand and create visual content. Remember, you were curious about how those massive data sets are actually created.
Yes, it's mind-boggling to think about the sheer volume of information these models need to learn. Where does it all come from?
Well, let's start with the basics. One of the most common types of data sets is called caption-based. These are collections of images or videos paired with descriptive text captions, like a digital scrapbook, with labels for each picture.
So it's like teaching the AI to see a picture and then describe it in words, connecting those two worlds together.
Exactly. And these caption-based data sets can be massive. Take Aeon, for example. It has billions of image-text pairs all scraped from the internet.
Wow, billions. So the AI is learning from the vast ocean of visual information that's already out there.
Precisely. And here's where things get interesting. Those captions aren't always perfect. Some might be inaccurate, some might be biased, reflecting the complexities of the real world.
So it's like learning to read a book with a few typos or scribbles in the margins. It might make you a more critical reader in the long run.
A great analogy. And these imperfections actually help the AI become more robust and adaptable. It learns to deal with the messiness of real-world data.
That makes sense. So caption-based data sets are like the foundation of multimodal understanding. But what about those AI models that can answer questions about images, the ones that go beyond just simple descriptions?
That's where conversation-based datasets come in. These datasets consist of images or videos paired with a series of questions and answers, like a dialogue about the visual content.
So instead of just passively observing, the AI is actively engaging with the image, trying to understand it on a deeper level.
Exactly. And these questions can get quite complex. They might involve counting objects, identifying relationships between those objects, or even understanding the sequence of events in a video.
It's like the AI is taking an exam, but instead of multiple choice questions, it's getting an image and a bunch of open-ended questions to answer.
That's a good way to put it. And these conversation-based datasets often build upon existing visual question. Answering datasets like VQA-V2 or WebVidQA researchers adapt those datasets for this more interactive, multimodal setting.
So we've got captions for basic understanding conversations, for deeper reasoning. But what about those models that can solve logic puzzles or perform complex tasks based on visual information? That seems like a whole other level of intelligence.
You're talking about reasoning-based datasets. These datasets are designed to push the boundaries of AI, testing its ability to go beyond simple perception and engage in more abstract cognitive tasks.
So instead of just recognizing a cat in a picture,
Yeah.
the AI has to understand that the cat is chasing a mouse and the mouse is running towards a hole and so on. It's about understanding the relationships and the logic behind what's happening.
Precisely. And these datasets often involve spatial reasoning, like CLAR, which presents images of objects and asks questions about their positions relative to each other. Or they might involve temporal reasoning, like NextKeyway, which tests the AI's understanding of the sequence of events in a video.
Wow, so we're not just training AI to see, we're training it to think. But with all these different types of data sets, how do we know which ones are the best? How do we compare these increasingly complex AI models?
That's where unified benchmarks come in. These are standardized tests designed to evaluate AI models across a wide range of tasks, from image captioning to video understanding to complex reasoning.
So it's like the SATs for AI, a way to measure their intelligence and compare them objectively.
A good analogy. And these benchmarks are crucial for driving progress in the field. They allow researchers to see which approaches are working, identify areas where AI still struggles, and track the overall advancement of multimodal generative AI.
It's like having a scorecard for the AI Olympics, a way to see who's taking home the gold in different events.
Exactly. And one trend we're seeing is the rise of integrated data sets. These data sets combine all those different flavors of information. We've talked about captions, conversations, reasoning examples, all in one big package.
So it's like a multimodal smorgasbord for the AI, a way to get a taste of everything and develop a more holistic understanding of the world.
A perfect analogy, LLV Instruct is a great example of this. It contains thousands of examples covering conversations, detailed descriptions, and complex reasoning tasks, all using both images and text.
That's impressive. It's like giving the AI a crash course in multimodal understanding all in one dataset.
It is. And as these data sets become more sophisticated, as we find better ways to capture and organize multimodal information, we can expect even more impressive leaps forward in AI capabilities.
This is all so fascinating. We've gone from simple image captions to complex reasoning datasets. It's incredible to see how far this field has come. But what about the limitations of these models? What are some of the challenges researchers are facing as they push the boundaries of multimodal AI?
That's a great question, and one we should definitely address. As impressive as these models are, they're not without their shortcomings.
So where do we go from here? What are the next frontiers in this ever-evolving world of AI?
Well, one of the biggest challenges is the sheer size of these models. We're talking billions, even trillions of parameters. And that scale comes with a cost.
Right. Not everyone has access to a supercomputer to run these massive AI models. It's like having a Ferrari in your garage but not being able to afford the gas.
Exactly. That's why lightweight AI is becoming increasingly important. We need to find ways to make these models more efficient without sacrificing performance so they can run on everyday devices like phones and laptops.
So it's like finding the sweet spot between power and portability. We want AI that can understand and generate complex visuals, but we also want it to be accessible to everyone.
Precisely. And researchers are exploring a variety of techniques to achieve this, from compressing existing models to designing entirely new architectures that are inherently more efficient. Think of it like streamlining a race car. We want to remove any unnecessary weight while still maintaining its speed and agility.
It sounds like there's a lot of clever engineering going on behind the scenes to make this AI magic more accessible.
There is, and some of the techniques are quite ingenious. For diffusion models, there's a lot of focus on reducing the number of sampling steps needed for generation. Remember that step-by-step denoising process we talked about?
Yeah, where the AI gradually refines the image, starting with pure noise.
Exactly. Well, instead of taking hundreds of tiny steps, researchers are exploring ways to get the same result with just a handful of larger leaps. Methods like distillation consistency models and flow matching are being explored to achieve this. It's like finding shortcuts in a maze, getting to the destination faster without sacrificing accuracy.
That's fascinating. And I'm guessing there are similar efforts to streamline the architectures of these models.
Absolutely. Techniques like quantization pruning, feature caching, and even neural architecture search are being used to slim down those bulky models without compromising too much on their capabilities. It's like Marie Kondoing the AI, getting rid of any unnecessary clutter and keeping only the essentials.
I love that analogy. It's like we're decluttering the AI's brain to make it run more smoothly.
Yeah.
So we're seeing a shift towards leaner, more agile AI systems designed to run on a wider range of devices.
Exactly.
Yeah.
And this trend towards lightweight AI is crucial for making multimodal generative AI truly ubiquitous, weaving it into the fabric of our everyday lives. But lightweight AI is just one piece of the puzzle. We also need to consider how these models will operate in more dynamic environments.
Right now, they mostly live in this controlled digital world.
Yeah.
What about AI that can interact with the real world, the messy, unpredictable world we live in?
You've hit upon a truly exciting frontier. Multimodal embodied AI. This is where we move beyond AI that just sits in a server rack and start thinking about AI that can perceive reason and act within the physical world.
So robots that can see, hear, understand, and even create. That sounds like something straight out of science fiction.
It's closer than you might think. Multimodal LLMs are already being used as the brains of robots, guiding their actions based on visual and auditory input.
So instead of just blindly following pre-programmed instructions, these robots can actually understand what they're seeing and hearing and make decisions based on that understanding.
Precisely. But there's a big difference between navigating a controlled lab environment and navigating the chaos of the real world. We need AI that can adapt to new situations, learn new concepts on the fly, and even recover from unexpected events.
So it's not just about intelligence, it's about resilience, adaptability, maybe even a bit of common sense.
You nailed it. And that's where things get really challenging. We need to develop new training techniques and architectures that allow these embodied AI systems to continually learn and evolve as they interact with the world. It's like raising a child. We teach them the basics, and then we give them the tools and the freedom to explore and learn on their own.
That's a great analogy.
Mm.
But how do we ensure these AI children learn the right things? The real world can be a pretty tough teacher.
One promising approach is to connect these AI systems to an online cloud, providing them with access to vast amounts of data and computational power. It's like giving them a lifeline to a super intelligent mentor that can guide their learning and development.
So if the AI encounters something it doesn't understand, it can send a query to the cloud and get an instant answer, along with some additional training data.
Exactly. And this cloud connection also allows for continuous updates and improvements. Imagine an embodied AI encountering a new object it doesn't recognize. It could send a query to the cloud, receive new information and training data, and then update its own model in real time, all without human intervention.
Wow, that's incredible. We're talking about AI that can learn and grow independently, becoming more knowledgeable and capable over time. But with all this talk about AI that can see, hear, understand, and even create, it makes me wonder, what does it all mean for us, for humans? Where do we fit into this future where AI is becoming increasingly capable?
That's a profound question, and one that we'll continue to explore in our next session.
Can't wait. Welcome back.
And
I'm still processing all these amazing possibilities of multimodal generative AI.
it's been quite a journey.
It has, from those foundational LLMs and diffusion models to the potential of embodied AI.
Yeah, interacting with the real world.
Last time we were talking about how this incredibly powerful AI is evolving,
Right.
but also how it might impact us humans.
Yeah.
Some people see it as a threat,
Yeah.
while others see it as a tool for incredible good. Where do you stand on this?
It's a topic that sparks a lot of debate, and for good reason. AI is becoming increasingly capable.
Right.
And it's natural to wonder how it will reshape our world.
Yeah.
But instead of framing it as a battle between humans and I like to think of it as a collaboration.
A collaboration.
Yeah.
So instead of replacing human creativity, AI could actually enhance it.
Exactly. Imagine artists using AI as a creative partner, exploring new forms of visual expression that were previously impossible.
Oh, wow.
Think of filmmakers weaving interactive narratives that blur the lines between reality and imagination.
Okay.
Or scientists using AI to visualize complex data in ways that lead to groundbreaking discoveries.
It's like giving every creative person a superpowered assistant.
Yeah.
One that can help them push the boundaries of what's possible.
Precisely.
Mm.
But for this collaboration to truly flourish, we need to make AI more accessible and intuitive.
Right.
It can't just be a tool for tech wizards. It needs to be something everyone can use and understand.
That makes sense. We need to break down those barriers between humans and AI,
Yeah.
making it easier for us to communicate and work together.
Yeah.
But even with user-friendly interfaces,
Right.
there's still the question of control.
Yeah.
How do we ensure that AI is used responsibly and ethically?
That's a crucial question, and one that deserves careful consideration. As AI becomes more powerful,
Right.
it's essential to have clear guidelines and safeguards in place.
Yeah.
We need to think about things like bias in data sets,
Okay.
the potential for misuse, and the importance of transparency and explainability.
We don't want AI to become a black box that makes decisions we don't understand or agree with. We need to be able to look under the hood and ensure that it's operating in a way that aligns with our values.
Exactly. And this is where the human element becomes even more important.
Yeah.
We need to be actively involved in shaping the development and deployment of AI, ensuring that it's used to benefit humanity, not harm it.
So it's not just about the technical advancements, it's also about the social and ethical implications. We need to be having these conversations now before AI becomes so integrated into our lives that it's impossible to turn back.
Absolutely. It's a shared responsibility. Researchers, developers, policymakers, and everyday citizens all have a role to play in ensuring that AI is used for good.
This has been an incredibly thought-provoking deep dive. We've explored the technical marvels of multimodal generative AI, but we've also touched upon the profound questions it raises about creativity, ethics, and the future of humanity itself.
It's a field that's constantly evolving, pushing us to reconsider our assumptions about what's possible and what it means to be human in an increasingly AI-powered world.
And to all our listeners out there, thank you for joining us on this incredible journey. We hope you've gained a deeper understanding of this transformative technology and the profound impact it's likely to have on our lives. Keep exploring, keep learning, and keep asking those big questions.
Until next time.